All right, guys, example number 3, it says, show that the following statements are true. Well, we just have one statement that we're going to do in this example. It says, show that the sine of a squared plus the cosine of a squared equals 1. Okay. Well, I don't have any numbers. Well, let's relax for a moment. Here, let's do this. Figure sine of angle A is equal to, here's angle A, opposite over hypotenuse, so A over C. And the cosine of angle A is equal to adjacent over hypotenuse, so B over C. Okay, now it says sine A squared, so that's going to be A over C squared, plus the cosine of A, that's B over C squared is equal to 1. I don't even know where this is going. Let's see where this is going. Alright, so this is going to give us A squared over C squared plus B squared over C squared is equal to 1. Okay, wait a minute. Now let's see, let's put these two together because they have a common denominator, right? So A squared plus B squared all over C squared is equal to 1. Now I don't like working with fractions, so I'm actually going to multiply both sides here by C squared. Do you see where this is going? C squared, and then I'm going to, that cancels with that, and it leaves me with A squared plus B squared, and on the other side I get C squared. Is that true? It certainly is true. We know that. That's something that we know. So we just proved that that was true. Nice. So if you take the sine of A and square it, and you add it to the cosine of A and square it, that gives you 1. Nice. Nice. Good job. Okay? We might have something like that for homework where you just have to plug in the numbers and make both sides equal each other, or give us something like that that we know the Pythagorean theorem. All right, let's look at this last one. What if tangent x equals 11 over 60? Find the sine of x and the cosine of x. Okay, now how do we go about doing this? Well, I've got an idea. All right, let's draw our triangle. Okay? And let's call this angle over here angle x. I don't know what these are. I'll just call it y and z. Okay, but that's angle x. And it says that the tangent is equal to 11 over 60. Well, remember, tangent, SOHCAHTOA, is equal to opposite over adjacent. But this tangent is also 11 over 60. So do you see, I'm going to make the opposite side equal 11 and the adjacent side equal 60 because that's what tangent equals. And here's angle x, opposite over adjacent. Okay? Well, if I've got these two, then I can figure out what C is, right? The hypotenuse. I can use Pythagoras. So we're going to get 11 squared plus 60 squared is equal to C squared. That's going to give us 121 plus 36 with 2 zeros, so 3,600 is equal to C squared. All right, I'm working on it. Give me a second. 3721 is equal to C squared. And then C, hold on. C is going to equal to, that adds up to 13. Man, I don't know if anything goes into 3721. Let me see what the square root is. I'm going to take my calculator. All right, square root of 3,721. Oh, are you kidding me? Of course, teachers. All right, take the square root of both sides. The square root of 3,721 is 61. I did not know that that was a Pythagorean triple, guys. I didn't remember that, that's for sure. Okay, so let's see. This side is 60, and now I know that the hypotenuse over here is 61. 11, 60, 61 gives us a Pythagorean triple, right? Pythagorean triples are combinations of the three sides that are all integers that work when a squared plus b squared equals c squared, and they're all integers rather than square roots of stuff. So, let's see. So now I need to find the sine of x. Well, the sine of angle x is equal to opposite over hypotenuse, so that's going to be 11 over 61. And the cosine of angle x is going to equal the adjacent over the hypotenuse, so 60 over 61. And that's it. Done. Done. I think you guys are ready. This is going to be some nice stuff. All right, I can't wait to see you in class tomorrow and go over some problems like this. I love trigonometry. It's really good stuff, and it's smart, you know. And you guys are smart because you're doing it. Okay, good job, guys. I'll see you tomorrow.